Hello friends, Assalamu alaikum. My name is Rahman Ali. I am from electrical department 20 batch. My roll number is 28. In this video we will talk about the some important questions of the advanced electrical machine subject, chapter number 2. So let's start it. The first question is that is the turn ratio of the transformer is same as the ratio of voltage across the transformer, why or why not? So the answer of this question that yes, in sense it is true, because the flux connecting the two coils in the same, it has been observed that the transformer ratio of voltages and ratio of turns are the same, so voltage will be directly proportional to the number of turns. जो जवाब है yes ये ट्रू होंदो आहे, छाकाणि त फ्लक्स जेको होंदो आहे ॿिनि कॉइल्स विच में वो सेम होंदो आहे। इन में अंदाज़ो लगाए सघूं था ट्रांसफार्मर जो जेको रेशियो ऑफ वोल्टेजिस होंदो आहे ऐं नंबर ऑफ टर्न्स जो जेको रेशियो होंदो आहे उहो सेम होंदो आहे, ऐं तंहिं करे वोल्टेज जेको होंदो आहे उहो डायरेक्टली प्रोपोर्शनल टू होंदो आहे नंबर ऑफ टर्न्स जे। Question number 2 is that why does the magnetization current impose an upper limit on the voltage applied to a transformer core? The answer of this question is that the coils wiring will ultimately burn out when a higher voltage is applied, because the core saturates and the magnetization current rises, causing an ohmic voltage drop. इन ॿिए क्वेश्चन जो जवाब आहे त जॾहिं असीं हायर वोल्टेज अप्लाइड कंदासीं त असांजो कोर जेको हूंदो आहे सेचुरेट थींदो ऐं मैग्नेटाइज़ेशन करंट प्रोड्यूस थींदो। जीअं ई असांजो करंट वधी वेंदो त जेको वायरिंग जेका हूंदी उहा बर्न आउट थी वेंदी। Now the third question is that what components compose the excitation current of a transformer? How are they modeled in the transformer's equivalent circuit? The answer of this question is that there are two parts of the thrilling current. First one is the core current loss. Second is the magnetization current. The core loss is the real power component owing to hysteresis and eddy currents revealed as heat generated in the core. The fourth question is that what is the leakage flux in the transformer? Why is it modeled in a transformer equivalent circuit as an inductor? The answer of this question is that leakage flux which saturates from the pole sides and is modeled as an inductor because it has an inductance as the flux that is merely wasting energy. The fifth question is that list and describe the types of losses that occur in a transformer. So there are three types of losses. First one is resistive, that is resistive loss or I2R losses or copper losses is the power loss in the transformer caused by the resistance of the copper wire used to make the widening. The second is eddy current loss. So eddy current loss is the power loss in the transformer or motor due to currents induced in the metal parts of the system from the changing magnetic flux. The third and last, that is hysteresis losses. Hysteresis losses is the loss caused by the magnetism that remains lags in the material after the magnetization force has been removed. Resistive losses उहे losses हूंदा आहिनि जेके असांजे रेजिस्टेंस जे करे प्रोड्यूस थियनि ऐं इन्हनि खे असीं कॉपर लॉसेस ऐं I2R लॉसेस बि चवंदा आहियूं। जेको सेकंड वन आहे एडी करंट लॉसेस। एडी करंट लॉसेस अहिड़ा लॉसेस हूंदा आहिनि जेके असांजा करंट जे करे प्रोड्यूस थींदा आहिनि ट्रांसफार्मर या मोटर जी कोर में, ऐं इहे जेके हूंदा आहिनि डायरेक्टली प्रोपोर्शनल हूंदा आहिनि वोल्टेजिस जे। द थर्ड एंड लास्ट हिस्टेरेसिस लॉसेस, दैट इहे हिस्टेरेसिस लॉसेस अहिड़ा लॉसेस हूंदा आहिनि जेके असांजे मैग्नेटिज़म जे करे प्रोड्यूस थींदा आहिनि। The question number 6 is why does the power factor of a load affect the voltage regulation of a transformer? The answer is the lagging power factor demands more current and it causes more voltage drop in the transformer winding. The second point is the load power factor also affects the transformer voltage regulation. Lagging power factor के वधिक डिमांड हूंदी आहे करंट जी, ऐं इन इहो ई सबबु आहे जो ट्रांसफार्मर वाइंडिंग में वधीक जेके हूंदा आहिनि वोल्टेज ड्रॉप थींदा आहिनि। The load power factor also affects the transformer voltage regulation जेको हूंदो आहे लोड पावर फैक्टर जेको हूंदो आहे इफेक्ट कंदो आहे ट्रांसफार्मर वोल्टेज रेगुलेशन ते। The question number 7 is why does the short circuit test essentially show only I square R losses and not excitation losses in the transformer? The answer is short circuit test only show I square losses because with low voltage there is minimal loss in excitation. This small loss is because the magnetization flux being very small. जीअं तो असांखे ख़बर आहे त जेको ट्रांसफार्मर जो सेकेंडरी पार्ट होंदो आहे उहो शॉर्ट सर्किट थियल हूंदो आहे। प्राइमरी वोल्टेज जेको हूंदो आहे उहो लोड सां कनेक्टेड हूंदो आहे छाकाणि त असांजो सेकेंडरी पॉइंट जेको हूंदो आहे आउटपुट न हूंदो आहे ऐं इहो ई कारण आहे जो असांजो प्राइमरी साइड्स खां हमेशह लॉसिस प्रोड्यूस थींदा आहिनि तंहिंजे करे असीं उन लॉसिस खे कापर लॉसिस बि चवंदा आहियूं। Now the question number 8 that why does the open circuit test essentially show only excitation losses and not I square R losses? The answer is that since the no load current is very small, it does not contribute to the copper loss. There is no load on the secondary side. अठें जो जवाब है त जॾहिं असांजो ओपन सर्किट टेस्ट में सेकेंडरी पॉइंट जेका हूंदी आहे उहा असांजी ओपन हूंदी आहे ऐं जेका प्राइमरी साइड हूंदी आहे उहा फुल रेटेड लाइन वोल्टेज सां कनेक्टेड हूंदी आहे तंहिंजे करे इहा असांखे एक्साइटेशन करंट जेका हूंदी आहे उहा ॾेखारींदी आहे तंहिंजे करे एक्साइटेशन जेके लॉसिस हूंदा आहिनि उहे असांजा रिज़ल्ट हूंदा आहिनि एडी लॉसिस ऐं हिस्टरेसिस लॉसिस जा। क्वेश्चन नंबर 9 इज़ हाउ डज़ द पर यूनिट सिस्टम ऑफ मेजरमेंट eliminate the problems of different voltage levels in a power system? The answer is per unit system provides the value of voltage, current, power, impedance and admittance. The per unit system also makes the calculation easier as all the values are taken in the same unit. जीअं त असांखे ख़बर हूंदी आहे त पर यूनिट वैल्यू जेको हूंदो आहे उहो इज़ इक्वल टू हूंदो आहे एक्चुअल वैल्यू इन एनी यूनिट डिवाइडेड बाय बेस आर रेफरेंस वैल्यू इन द सेम यूनिट। नाउ द क्वेश्चन नंबर 10 is why can auto transformers handle more power than conventional transformer of the same size? The answer is the single winding make an auto transformers leakage flux and resistance low compared to the traditional transformers high value. Comparing the auto converters to a traditional transformers, the former is more effective. इन जो जवाब इहो आहे त लीकेज फ्लक्स ऐं रेजिस्टेंस जेका हूंदी आहे ऑटो ट्रांसफार्मर्स में लो हूंदी आहे छाकाणि त इन में सिर्फ़ु हिक ई वाइंडिंग हूंदी आहे तंहिंजे करे इहे असांजा हाई कन्वेंशनल ट्रांसफार्मर्स हूंदा आहिनि। ऑटो ट्रांसफार्मर जेके हूंदा आहिनि असांजा मोर एफिशिएंट हूंदा आहिनि एज़ कंपेयर टू द कन्वेंशनल ट्रांसफार्मर्स। द क्वेश्चन नंबर 11 इज़ दैट व्हाट आर ट्रांसफार्मर टाइप्स, व्हाई are they used? The answer is that the answer of 11th question that transformer connection make it possible to alter the voltage ratio and consequently the coil ratio. If the input voltage deviates from the nominal voltage, this is used to modify the output voltage. It means that transformer taps allow the coil ratio and therefore voltage ratio to be changed. This is used to adjust the output voltage if the input voltage differs from the nominal voltage. The question number 12 is what are the problems associated with the YY three-phase transformer connections? The answer is that the phase voltage have a tendency to become severely out of balance if the neutral connections is absent and a load that is not balanced is attached. Thus, in the lack of neutral connections and the star-star connections is insufficient from the unbalanced loadings. It means that if the neutral connections is not provided and an unbalanced load is connected, then the phase voltages tend to become severely unbalanced. Thus, the star-star connections is not satisfactory for the unbalanced loading in the absence of a neutral connection. क्वेश्चन बारे जो मतलब आहे त जेको असांजो वाई कनेक्शन हूंदो आहे जंहिंखे असीं स्टार कनेक्शन्स बि चवंदा आहियूं जेकॾहिं असीं इन में न्यूट्रल पॉइंट जेका अटैच नथा कयूं ऐं जेको लोड अनबैलेंस लोड जेकॾहिं कनेक्ट कयूं था त असांजो फेस वोल्टेज हूंदो आहे उहो severely जेको हूंदो आहे उहो अनबैलेंस थी वेंदो आहे। क्वेश्चन नंबर 13 इज़ व्हाट इज़ TCUL transformers? The answer is that the transformers known as TCUL, the full form of TCUL is that tape change under load. Transformer has several taps, each with different turn ratio, enabling the voltage reduction from the primary side to be changed. Additional referred to as load tape changing LTC converters. Question number 13 जेको TCUL ट्रांसफार्मर छा चयो वेंदो आहे तंहिंजो मतिलबु आहे TCUL ट्रांसफार्मर जेका हूंदा आहिनि उहे असांजा मल्टीपल टैप्स ते मुश्तमिल हूंदा आहिनि। इहे जेके हूंदा आहिनि असांजा वोल्टेज रिडक्शन खे घटि करण जे लाइ हूंदा आहिनि जेके असांजी प्राइमरी साइड खां वोल्टेज हूंदा आहिनि। TCUL ट्रांसफार्मर खे असीं LTC बि चवंदा आहियूं। इट मीन्स लोड टेप चेंजिंग ट्रांसफार्मर्स। Question number 14 is that how can three-phase transformation be accomplished using only two transformers? Why? What type of connections can be used? What are their advantages and disadvantages? The answer is that there is the method of performing three-phase transformation with just two converters. Two conventional. First one is that two conventional single-phase transformers are the simplest method to convert three-phase voltage to two-phase voltages. The second is that on the main three-phase side, the first transformer is connected to phase to neutral, and the second is connection between the other two phases. Four connections is that Y-Y connection, Y-delta connection, delta-Y connection, and the last is delta-delta connection. It means that there is technique to do three-phase transformers with the use of two transformers. The main point is that the easiest way to transform three-phase voltage into two-phase voltages is with two conventional single-phase transformers. The first transformer is connected to phase to neutral on the primary side, and the second transformer is connected between the others two phases on the primary side. Now the advantage is that inexpensive, the first one, and the second one is lightweight, and third is assembly in the least time, the fourth is higher efficiency, and fifth is easier to install, and last is easy transportation. And the other is that disadvantages. The first is the more significant cost of standby units. The second is cost of repair. It means it's a high cost for the repair, and the third is reduced capacity, and the last is fault correction. Question number 15 is that explain why the open transformer connections is limited to supplying 57.7% of a normal transformer bank's load. The answer is that transformer with reduced impedance have low voltage unbalance. This is the cause of the open delta transformers 57.7% electricity output. Question number 15 जो मतलब आहे त वोल्टेज जेका अनबैलेंस हूंदी आहे उहा लेस हूंदी आहे लोअर इम्पीडेंस ट्रांसफार्मर्स जे जंहिंजो इहो ई कारण आहे त पावर आउटपुट जेका हूंदी आहे ओपन डेल्टा ट्रांसफार्मर्स में जंहिंजी परसेंटेज हूंदी आहे 57.7%, मीन्स के 57.7%. Question number 16 is that can a 60 Hz transformers be operated on a 50 Hz system? What actions are necessary to enable these operations? So the answer is that no. However, a 60 Hz transformer's applied voltage must also be reduced by 1/6 in order to work on 50 Hz. Otherwise, the peak flux in the core will be too high. It means that no, but if a 60 Hz transformer is to be operated on 50 Hz, its applied voltage must also be reduced by 1/6 or the peak flux in the core will be too high. Now the question number is 17. What happens to a transformer when it is first connected to a power line? Can anything be done to mitigate this problem? The answer is that zero cross switches can be used to turn it on and off to get around the problems of it turning into a coil and an electromagnet. It means that it becomes a coil and an electromagnet. This can be overcome by using zero cross relays to power it on and off. Now the question number is 18, that what is potential transformers, how is it used? The answer is that the potential transformers is PT transformer is an instrument transformers used in power system for measurement and protection reasons. In a power system, it is primarily used to monitor high alternating voltage. इन जो मतलब ये है तो असी पोटेंशियल ट्रांसफार्मर उन जगह ते यूज़ करना हो जिते असांखे मेजरमेंट जी ज़रूरत पवंदी आहे प्रोटेक्शन रीजन्स जे लाइ। जेकॾहिं असी हाई वोल्टेज या हाई करंट खे मालूम करणु चाहियूं त पोइ असांखे पोटेंशियल ट्रांसफार्मर जी ज़रूरत पवंदी। छाकाणि त जेकॾहिं असी हाई वोल्टेज खे हिकु सिंपल मल्टीमीटर ते यूज़ कंदासीं, मीन्स के उन ते मेजर कंदासीं त उन जी प्रोटेक्शन न थींदी, उहो असांजो डैमेज थी पवंदो। ठीकु आहे, उन खे बाहि वग़ैरह लॻी सघे थी। उन जे लाइ असी पोटेंशियल ट्रांसफार्मर हणंदा आहियूं जीअं असी उन हाई वोल्टेज या हाई करंट खे असी मालूम करे सघूं। नाउ द क्वेश्चन नंबर 19, what are the current transformers, how is it used? The answer is that the tool used to gauge the current in another circuit is current converters or CT. Across the national electricity grids, CTs are used to monitor high voltage lines. It means that a current transformer is a device that is used to measure the current of another circuit. Another point is CTs are used worldwide to monitor high voltage lines across national power grids. Now the second last question is 20 number question, that a distribution transformer rated at 18 kVA 2000 by 480 volts and 60 hertz. Can this transformer safely supply 15,000 kVA to a 415 volt load at 50 hertz? Why or why not? The answer is that three things have an impact on this use. Unless the transformer has adjustable taps on the windings, you will need a 17,292 volt intake for a 415 volts output at a lesser frequency. The saturation of the core might start to matter if the transformer depends on tap changes to get the correct ratio of input to output. You must be conscious of the various voltage to current ratios associated with using various tap settings. The current at 415 volts is a little bit less at specific out voltages you indicate. Therefore, it is unlikely to overheat the windings. The last question number 21, why does one hear hum when standing near a large power transformer? The answer is that electric currents influence a transformer's internal structure and create vibration, which result is an audible hum. So finally, the important question of the chapter number 2 transformer is completed. So thanks for your concentration. Thanks for watching. Allah Hafiz.